Rhino. So tonight our speaker is Erik Johnson. Most of you are probably familiar with Erik. He's been around in the birding community in Louisiana for quite some time now. He is the Director of Conservation Science for Audubon Delta, a regional field office of the National Audubon Society that covers Louisiana, Mississippi, and Arkansas. With Audubon, he oversees conservation planning and implementation, habitat management initiatives, and applied scientific research focused on species of conservation concern. Before joining Audubon, Erik conducted his graduate work at LSU, studying the effects of deforestation on bird communities in Amazonian Brazil, and the effects of fire on wintering Henslow sparrows in southeastern Louisiana. Some of you may have participated in his Henslow sparrow rodeos, which was quite an experience. A lifelong birder, Erik is actively involved in Louisiana's birding community, serving as Louisiana's regional editor for the Christmas bird count, director of the Louisiana Bird Observatory, a member of the Louisiana Bird Records Committee, a board member of the Inland Bird Banding Association, and a certified trainer with the North American Banding Council. He is also a volunteer board member with Baton Rouge Audubon. Erik lives in Sunset, Louisiana with his wife, Cece, where they enjoy gardening for wildlife and caring for their horses, dogs, and indoor cats. With that, Erik, you may take it away.
Thank you. So good to see you all. Thanks for coming. Thanks for spending an evening with me. Let me go ahead and share my screen. I've actually decided to change the entire talk, and we're going to focus on leafhoppers. I'm actually just kidding. I am going to talk about birds. But if you haven't explored the world of insects, it is limitless. You think birding is hard, wait till you get into insects. But they are the base for all things birds. And we'll be touching back on insects here and there throughout the talk. But yeah, so I'm going to talk about the Mississippi River and its importance for birds throughout North America. I'm going to weave a web and talk a little bit also about bird migration in the region, and I'm going to end the talk with some of the things that Audubon is doing in coastal Louisiana to help reintroduce the river in ways to sustain our coastal wetlands. So, as Jane said, she mentioned that I work for a field office of the National Audubon Society that's now called Audubon Delta. So many of you probably know me as formerly working for Audubon Louisiana, which was a state office of the National Audubon Society, and that's kind of merged with two other state offices. We had few enough staff in each of the three states, but also enough really good expertise across these three states that it made sense to combine our varied experiences and our various backgrounds to implement larger scale restoration initiatives across the region. And one of the big things we're actually working on right now is a conservation blueprint for the lower Mississippi River alluvial valley. And I won't talk about that so much because it's still very in the early stages, but hopefully in the coming months, we'll have that plan kind of more solidified, and we're looking to attract some funding that'll help expand some of the initiatives I'll be talking about today. So, we continue to focus on the things that Audubon Louisiana has been doing for a number of years, which include coastal restoration, management, advocacy, science, policy. We're deeply involved in advancing renewable energy initiatives. We're engaged with the climate task force that the state of Louisiana has put together. We're a big advocate for native plants for birds. And in fact, one of our programs in Arkansas actually works with minority and veteran farmers to grow native seeds that are then harvested and used for prairie restoration, which is a really cool program that we're looking to expand into Louisiana and Mississippi as well. So what's new with Audubon is we have welcomed Dr. Dawn O'Neill, who is going to lead the Delta region as our executive director. She has a PhD in ornithology. She has a background in research, but also land management and strategic initiatives with the Nature Conservancy before coming to Audubon. So we're really excited to have her on board. Like I said, we're sort of leveraging our resources and knowledge across the states. We're developing this conservation blueprint. And these are kind of like the pieces of infrastructure that we have as the National Audubon Society across these 3 states. We have an education center in Pascagoula. We have a education center in North Mississippi called Strawberry Plains, which if you've never had the chance to visit, it's absolutely a beautiful property, a mix of prairie and forest, and it's world famous for its hummingbird festival. Something like thousands and thousands and thousands, up to 7,000 people attend that festival every year. We have an education center in Little Rock that does a lot of great work. It's entirely solar powered now, which is really sort of an exciting advance. We have our Mississippi River Delta Coalition headquarters based in New Orleans, and Audubon's oldest and largest sanctuary, the 26,000 acre Paul J. Rainey Sanctuary, is located right here in coastal Louisiana. So I'm very fortunate that I get to work across a lot of these places and work with various staff implementing different conservation initiatives. So I'm going to talk a little bit about the Mississippi River and just kind of why it's unique from a bird standpoint. So this image here indicates a lot of the major rivers across the world. You can see the Amazon River in South America, the Nile, and so on and so forth. But one of the things that really stands out to me with the Mississippi is the fact that it runs north-south. It's actually fairly unique among the major river systems in the world, which means it plays a very important role in diversifying the bird life of the continent and serves as a major flyway for migratory birds, particularly birds that depend on water and habitats that are associated with water, like bottomland hardwood forests and swamps and things like that. So it's an incredibly central feature of the continent and its bird life. So I'm going to kind of go through the watershed and just kind of briefly highlight some of the major habitats that the Mississippi River sustains and has created over the many centuries. So in the Northern Lakes region, it's a beautiful landscape. I actually got my first wildlife job up in northern Wisconsin one summer, helping somebody study common loons in this region. It's very special, and most of those common loons actually winter on the Gulf Coast, connected by the Mississippi River. The prairie potholes, which is the breadbasket for most of the waterfowl of the continent, also are the same birds that come down to Louisiana that many people enjoy watching and hunting and provide habitat for. And again, the Mississippi River kind of connects these birds across the continent. Further to the west, the Great Plains is shaped by the river with kind of lowland, flat, sediment-rich, nutrient-rich plains that support a variety of birds like Henslow sparrows, dick thistles, and so on. The bottomland hardwood forests are probably what a lot of people think of when they think of the Mississippi River. That swamp habitat is one of the most important places in the world for prothonotary warbler and many other species, swallowtail kite, Swainson's warbler, so on and so forth. And the tributaries of the Mississippi help shape the eastern forests, the ridges and valleys throughout that part of the continent, which supports things like a lot of the migrants that we see coming through Louisiana. They're the breeding grounds for things like summer scarlet tanager and yellow warbler, and many of the other varieties of candy birds that I like to call them. They're really colorful birds that come through coastal Louisiana each year. And then, of course, the Appalachians form the eastern boundary of the Mississippi River watershed, and species like hermit thrush nest up there and come down to the south for the winter. As we get closer to home, the piney woods of the lower Mississippi River and the kind of more upper upland areas Sorry, my internet just jumped for a second.
Okay.
Can y'all hear me?
You were muted. for a moment. There we go.
Yeah, I lost my internet connection. Sorry. I'm on Zoom calls like literally, 6 hours a day, and that doesn't happen until I do these things in the evening.
I feel your pain. I'm right there with you.
So I apologize if it happens again. So on to the next habitat are, all right, get going here, are the coastal plains. So this serves as the wintering ground for many species further north. Things like Henslow sparrows, one of my favorites. Swamp sparrows, Lincolns, LeContes, all the little brown jobbies that come down to our region that drive birders nuts, but are really cool once you get to know them. And of course, the Mississippi River empties into coastal Louisiana through its delta and produces this incredibly rich ecosystem of coastal wetlands, which in and of itself is not just one monolithic type of habitat. They're incredibly diverse, supporting this rich estuary environment, ranging from freshwater marshes that support things like the king rail pictured here, through intermediate and brackish marshes down to the salt marshes that support clapper rails, creates the Cheniere ridges, and all those kinds of habitats that we're familiar with in South Louisiana, all shaped by the river. And so you put it all together, and the diversity of bird life that's shaped by the river is absolutely astounding. Hundreds and hundreds of species of birds use the river. Something like 340 species of migratory birds navigate north and south along the river. And of course, the river is just a small portion of the migration for some of these really epic migrants. Things like buff-breasted sandpiper that nest all the way up in the Arctic, use the Mississippi River, follow the Mississippi River south, and then continue on to southern South America where they spend the winter, and then make that trip again up north each spring. So it really connects birds across the Mississippi Flyway, across the hemisphere, between North and South America. And this graphic here was put together by the geniuses of Cornell Lab of Ornithology. Each one of these dots represents the centroid of a species distribution. There's about 121 species represented here. And as the Earth is circling around the sun, all of these birds are following the summer. As the northern hemisphere gets cool, the southern hemisphere warms, and vice versa. And of course, a whole variety of birds, from hummingbirds to raptors to buntings to waterfowl, or have figured out this strategy of migration. And again, just look how many come through the Gulf of Mexico and up the Mississippi Flyway. It's just, again, so hard to overemphasize the importance of the habitats that the river sustains. So I'm going to get a little bit more into the ecology of migration, right? So why do birds do it? And I kind of hinted at it, right? As the Earth is rotating around the sun, the Earth has an angle, it tilts on its axis. And so that creates seasons where the portions of the Earth are pointed away from the sun, and portions of the season when the Earth is pointed towards the sun. And so birds migrate to follow that river to maintain their ability to find food, and of course to breed. So they take advantage of the warm summers to take advantage of the insects that are produced, that then are used to feed their young and raise their fledglings. And migration is not just one thing across birds. Migration has actually evolved dozens and dozens and dozens of times among birds in North America. And so there's lots of different strategies that birds utilize to migrate. Some birds are what we call complete or obligate migrants, meaning that every single individual of the species migrates. It's often dictated by things like day length. And usually we think about it as being latitudinal, so birds moving north and south. But it can also be elevational. And in the Rockies, things like rosy finches are elevational migrants. Once you get into the tropics, into Central America and the Andes, in South America, you have lots of elevational migrants that are moving up and down slope in response to seasonal changes. You have other kinds of migration that ornithologists consider to be partial, right? So that's when some individuals of a species migrates, but not all of them. So good examples of that include things like brown pelican and royal tern. Many of them hang around in the northern Gulf of Mexico throughout the year, but other individuals will actually fly across the Gulf, fly into the Caribbean, and migrate south for the winter. And it's still a little bit mysterious to ornithologists why certain individuals migrate and others don't. It's a really interesting strategy. And then you have things like eruptive migrations. And so these are more dictated less by day length and sort of abiotic features, but is much more dictated by the abundance, the pulses and waning of food resources. So many of you may remember the pine siskin eruption, and even we were talking about the evening grosbeak eruption last winter. Those are examples of eruptive migrants where you have years of really good food resources that build up populations. Those birds don't have to migrate south to find food, and then all of a sudden the food resource crashes, and that drives those birds much further south than they normally would go in the winter. So those cycles often happen on 2, 3, 4, 5 year intervals, and can be really hard to predict. But this group called the Finch Network has done a really good job in starting to figure out what drives these eruptive migrations each year. And almost any day now, we can expect the finch forecast for the winter. We're already seeing lots of red-breasted nuthatches coming south this winter, so maybe we're going to get a little bit of an eruption again this year. Some birds, they migrate during the day, right? So things like hawks, they take advantage of the sun's energy. When the sun hits the earth and heats the earth, it bounces off the surface and creates these thermals. And that rising warm air is something that hawks actually take advantage of and will gain altitude by catching those thermals without having to expend any energy. And then once they get high enough, they'll peel off thermal and head south for the fall. They head north in the spring and really use the sun's energy in order to migrate. They barely flap the entire time. But other birds will migrate at night. Many songbirds, in fact, almost all of them migrate primarily at night. They take off at sundown, and they take advantage of the more stable air because they actually have to power their flight. They flap, they have to fuel their migration by eating tons of food in order to make these epic journeys. And actually we're going to get this cold front coming through. We're going to have a lot of birds migrating south in the next few days. As the moon begins to become more full over the next week or so, you might actually see something like this. If you look up at the moon with your binoculars, you can actually see birds passing in front of the moon at night during migration. And if you have good ears, you might even hear them giving their little flight calls, so little chips, as they're migrating over. And you can see migration even with radar. And so this has become more and more popular to birders. Ornithologists have known about it for many years. And the tools and technologies to quantify how many birds are moving based on radar data is becoming more advanced. But it's really cool. You can kind of see on any given night how many birds are up in the air within your region. So this is an example of a spring night in across the United States. This first graph here is this first image is at sundown. You don't really see much. You can see some weather patterns up north, some rain. But then 15 minutes after sundown, the sky starts to light up with birds being detected by radar, and this is 30 minutes after sundown. All of these birds are taking off and lifting up into the air where the radar beam is detecting them, just like the radar beam would detect particles of rain. So pretty cool. You can actually go into the internet tonight and open up a radar system and see if birds are migrating. And in fact, tonight's not going to be a very good night for Louisiana, but Saturday night, Sunday night, Monday night will be great. So it'll be fun to watch. And then, so that's kind of when birds migrate, how they do it, but how they guide themselves, how they orient themselves is a whole other really fascinating aspect of bird migration. Many birds, especially birds that migrate at night, are using various compass mechanisms. So they can either use polarized light from the angle of the sun. So if you've ever worn polarized sunglasses, you can kind of change your head and the sky changes color. And so it's kind of that feature that birds can key in on and use that to orient themselves during migration. Many birds will also utilize the stars to migrate. They can actually sense the magnetic field. And in fact, there's evidence coming out that they can see the magnetic field and use that to migrate. And of course, many birds are probably using combinations of these things to become really, really accurate in orienting themselves during migration. Birds that migrate during the day will actually learn maps. Things like cranes that migrate during the day will learn the routes from their parents and develop a map system in their head, and learn how to navigate that migration in future years. So I'm back. Cut out again. Yeah, so I was saying the maps of cranes are passed down from generation to generation, whereas things like songbirds, it's just innate. It's genetically programmed for them to figure out how to migrate. It's all embedded within their genome. So some of the ways that ornithologists learned about how birds orient themselves have to do with putting birds in flight cages when they are exhibiting what's called migratory restlessness. The time of the year when they're supposed to be migrating, if you put a bird in a cage, it will start orienting itself. It'll try to fly and move in the direction that it's supposed to migrate. So for example, this European robin in spring, you put it in a cage and it's going to orient itself to migrate north. But you can do experiments with these birds, and researchers recently did this, and they covered up the right eye and left the left eye open, and the bird no longer knew how to migrate. It didn't know which way to go. But when it covered its left eye and left the right eye open, there was something in the right eye that allowed the bird to reorient itself and migrate in the correct direction. And so from that, researchers figured out that birds are actually seeing with their right eye the magnetic field. There are these structures within the eye called cryptochrome sensors. They're kind of blue light type sensors that are specifically designed to test magnetic fields. I am not a physiologist. I don't know the physiology of exactly how that works. It's apparently really complicated, and it's really hard to imagine as a human to know what it's like to see the magnetic field. But like in this former image, right, the magnetic field has bands around the Earth, and depending on where you are in the Earth and the direction that you're looking, the angle of that field changes. And so the thought is that birds are actually visualizing that angle of the magnetic field, and it might look something like this, as sort of this extra bright area in the sky. And as birds are turning their heads left and right, they can kind of figure out which direction to go. Mind-blowing, right? Just completely mind-blowing that birds are able to see this in order to migrate. So birds have been doing this for millions of years, and we're just catching up and figuring out how they do it and how even individual birds are making these journeys. And so researchers and ornithologists for years have been trying to figure out how to track individual songbirds as they make these journeys. And the real first successful attempt of this was done in about 1962. These researchers put what's called very high frequency transmitters. It's basically a transmitter that sends out a signal that you can receive with a special antenna and detect the signal. It transmits the signal on a very specific frequency, and so you could put these tags on various birds, but generally speaking, you have to slightly tweak the frequency for each bird to be able to tell them apart. So anyway, so they put these tags on the birds, and then guess how they followed them during migration. They did not run really fast after the birds, but it was something pretty close to that. in their cars and they jumped in an airplane and started following birds with these tags attached to start to get a sense of how far they were migrating. And of course, the birds outflew the planes ran out of gas, the cars ran out of gas, they couldn't keep up, they didn't have the right roads. But they were able to develop this map of about, 15 different birds, individual thrushes that were making its spring migration. So kind of cool, this is sort of a proof of concept that we could begin to detect how individual birds were moving across the landscape, which of course then opens up all kinds of questions, right? About what do individual birds need? What habitats are they using? How long are they spending in those habitats? What are they eating in those habitats, right? And so it kind of opens up this whole other world of understanding the threats that birds face and the opportunities that they have in order to successfully migrate. Fast forward to today, 60 years later, and we have so many more tools at our disposal to understand how individual birds migrate. There are satellites now that can detect tags that are put on larger birds, that can track birds in real time. A researcher just has to capture the bird and then sit at its computer and let the satellite do the work. It'll download the data to the computer, and you can follow birds in real time that way. There are GPS trackers now, which some of them are made small enough now, they don't transmit any information. You have to recover that bird in the GPS sometime later, and all the data will be stored on that GPS. A similar kind of technology is called a geolocator. I'm going to talk a little bit more about that. You have to collects all this light data, and you have to collect that tag off the bird sometime later to see where it's been. There are, again, these VHF transmitters, but instead now of having to use slightly different frequencies for individual birds, you can put all your tags on a single frequency and put an embedded code within the tag, within the signal, that then a computer can interpolate and figure out which bird is which based on that little unique signal. There are RFID tags, which are very small, that can be used to track local movements of birds, but the bird has to be fairly close to the reader. So, but it just sort of opens up this array of opportunities to study birds. So I'm going to talk a little bit about some work we did right here in Baton Rouge on studying the migration of prothonotary warblers. Baton Rouge Audubon was actually the organization that was instrumental in getting this started. They helped fund the purchase of the first 3 tags of prothonotary warblers that we deployed, that anyone had successfully recovered. So a little bit about the prothonotary warbler. In addition to being incredibly gorgeous, I like to call them swamp candles because they're just stellar birds. They arrive in North America and the United States in the spring. They breed in our swamps. Louisiana supports something like 25% of the world population, but the breed population, of course. And then they migrate south for the winter. They go to places like Central, Northern South America. But they're, otherwise, we don't know a lot about what they need once they leave the United States. And you can see they're really only here for a few months of the year. So the way we address that is we bought those geolocators, and you can attach them to birds like a little fanny pack around the waist of a bird. And what a geolocator does is measure light, the ambient light in the world around the bird every 2 minutes. And it stores that information into a little database, and it's logged with the timestamp. And so then you kind of let the bird go with the geolocator attached. It goes about its business. It comes back a year later, and then you have to refine that bird, relocate the bird, and then recapture the bird to recover all the data off the geolocator. And day length will give you latitude. So think about it in the summer, right? The further north you go, the longer the day length is. As you go further south, the shorter, and that flips in the winter. So, and then solar noon is dictated by, it can give you longitudinal information, right? The sun always rises earlier in the east. And so the timing of sunrise and solar noon and sunset will give you longitude with some error, right? About 100 kilometers, 150 kilometers plus or minus. But it gives you a pretty good sense of the vast areas that birds are using. These geolocators weigh less than 4% of a bird's body weight. So a prothonotary warbler weighs about 15 grams, which is the equivalent of 5 pennies, right? Five of these little pennies are the weight of a prothonotary warbler, and a geolocator weighs 4% of that. So really, really lightweight devices that are super safe to the bird. But you must be wondering, how the heck do you catch a prothonotary warbler? Well, you have to use a very convincing decoy that looks almost exactly like a prothonotary warbler in that it is bright yellow. And that's all you really need. It could actually be a magic marker. It could be like a glob of clay. It doesn't have to be anything all that specific. But if you do that along with playing the song of the male, he will come screaming in to chase off the intruder, and you can safely catch him with a mist net. Of course, it does require federal and state permits because birds are protected. And so researchers like myself spend a lot of time getting these permits and the training to do this safely for the birds. So we did that on 3 birds in Baton Rouge at Bluebonnet Swamp. One bird immediately dropped its geolocator after we deployed it. We kind of messed up. We didn't attach it right. We were still kind of learning as we went. And of course, the geolocator disappeared into the swamp somewhere. We never found it. A second bird was given to a male that quickly disappeared. It probably wasn't a territorial bird, just moving through. And so there was one bird left that got its geolocator. It was using one of the nest boxes we put out, and it successfully raised its young. We could see it all through the summer, continuing to carry its geolocator. And then in August, that bird left. It disappeared. And so we waited and we waited, and then it got cold in December and January and February. And on March 24th, we got a call from John Hartgerink, who's a great volunteer, great naturalist out at the swamp. And he's like, I have a banded prothonotary warbler. I think it's carrying a geolocator. And sure enough, it was that bird. So we dropped everything, ran out, caught the bird, downloaded the data, and this is what we discovered about the first tracked prothonotary warbler. It headed all the way to Colombia. It left Baton Rouge in late July and staged on the Louisiana coast, flew across the Gulf of Mexico, spent about a month and a half in the Yucatan Peninsula. Instead of going south, it went over to Cuba, then spent like another month in Jamaica, and then crossed the Caribbean, where it finally reached its wintering destination 3.5 months later in northwestern Colombia. Spent the winter there, and then made a beeline back to Baton Rouge in early March, flew across the Gulf of Mexico. It departed the Yucatan Peninsula on the night of March 23rd, and John found the bird singing within about 100 meters of its previous year's nest box on March 24th. These birds migrate at night, remember, so it left at sundown, flew probably something like 18 hours, and didn't even stop on the coast. It went straight to Bluebonnet Swamp. So, you know, the 600-mile plus flight, plus or minus flight. And if it were off by a fraction of a degree, it would have ended up in Mississippi or Texas or something like that. The precision of a bird being able to navigate across that distance was absolutely remarkable. And so, you know, it's a pretty epic migration. But that really, you know, tells us about one bird, and think about all of the places that that bird needs. What about other prothonotary warblers in other places? So we started a working group of researchers studying prothonotary warblers, and we all started deploying geolocators in 6 different states across the country. And what we found is that regardless of the breeding origin, these birds were wintering in northern Colombia, primarily centered on the Magdalena River Valley, which is like a mirror opposite of the Mississippi River. So this is a bird that depends on the Mississippi River and its bottomland hardwood forests during the nesting season, and it depends on a major river system in the winter in northern Colombia. We also were able to identify really important stopover locations where almost every single bird spent multiple days in the Yucatan, in Central America. And so this has really important conservation implications. We're also able to show that birds in Wisconsin, primarily use the Mississippi flyway, same with the birds in Arkansas, whereas the eastern birds kind of took a more Caribbean route before eventually meeting up with the Mississippi flyway birds. They all met up in Central America and then went to Colombia. So we were able to figure out what sort of the key links of the migration chain is for this species. It's the Louisiana, supporting something like a quarter of the world population, these key hotspots of migration in Central America, and then the overwintering sites in Colombia. And this was really unexpected. We didn't expect birds from the eastern and the western part of the population to be spending the winter together. In most other songbirds where similar research has been done in the last 10 years or so, many birds are showing what we call high connectivity, meaning that birds in the eastern part of the breeding range spend the winter in the eastern part of the wintering range, and vice versa. Birds in the western part of the breeding range spend the winter in the western part of the wintering range, meaning that they don't mix and overlap. So if you're investing conservation resources in particular places, let's say on the wintering grounds, it's really important to know what proportion of the breeding population that you're supporting. In something like Prothonotary warbler, if we put an investment in Northern Colombia, we know we're going to benefit Prothonotary warblers all over the United States. If we put an investment of conservation in Northern Colombia for, say, the American redstart, we're really probably only benefiting populations that breed in the southeastern United States. And so the reason why this is important, right, to understand how these birds are spending their entire life cycle, is because migratory birds are disappearing. Sadly, about 2 in 5 Baltimore Orioles have disappeared since the 1970s. A total of 2.5 billion birds, or about 30% of the US and Canada population of migratory birds, have disappeared in the last 50 years. That's within most of our lifetimes. About 1/3 of all the birds that were in the world when many of us were young children or just born, or a glint in our parents' eyes, have disappeared in our lifetime. The causes of this are habitat loss, clearly. We're converting too much land to modify for human benefits like agriculture and urbanization and those kinds of things. But outdoor and feral cats are a big issue. Window collisions are a big issue. Right now, we're in the peak of bird migration, and I'm seeing all over Facebook people talking about, asking for an identification of this bird that hit their window. It's almost always a migratory bird that's hit somebody's window. And so there are things that you can do to help birds just on your own property, around your own home, to help birds. If you go to 3billionbirds.org, there are some really great resources to help you minimize the issues of things like window collisions, to give you some guidance on how to do native plantings to benefit birds, things like that. The Prothonotary warbler is like a lot of other migratory birds. They disappeared by 40% since the 1960s. If you consider how much bottomland hardwood forest has been lost over that time, they've outpaced the loss of breeding habitat. Their declines are faster than they're losing breeding habitat. But if you start to consider the kinds of habitats they use in the winter, it much more closely explains the loss of birds. So in a bird like Prothonotary warbler and Baltimore Oriole and American redstart, no matter how much we do to conserve habitat in the United States and Canada, it will not be enough if we don't also address the habitat needs for these birds in Central and South America. It's absolutely crucial to make sure that every link in the migratory chain is conserved. The other thing to consider, right? So a lot of the bird data we have started being collected in the 1960s in terms of how populations were doing. But most of the Mississippi River, lower Mississippi River alluvial valley was clear cut prior to the 1960s. Something like 80% of that habitat was lost by 1991, well before the declines that we're seeing today. So the the few prothonotary warblers that are remaining, right? The 60% that are still remaining from the 1970s, there were many, many, many more in the times before the 1970s. That Mississippi River and its habitat has been so incredibly important for birds, and we're only left with a small fragment of that. And it's resulted in avian extinction, frankly, right? The ivory-billed woodpecker, which the U.S. Fish and Wildlife Service just released like a week or two ago, that they are declaring the ivory-billed woodpecker extinct. The Bachman's warbler is another species that's been lost from our bottomland hardwood forest, now thought to be extinct. And so, you know, for those of us who love birds, this is tragic. But birds matter much more than just for our own enjoyment. They're incredible sentinels of ecosystem health. The decline that birds are facing today is a clear signal that something is wrong in our environment. We need healthy land, healthy air, and healthy water for birds, and those things are the very same things that benefit people. I'm going to shift gears a little bit again and talk about South Louisiana, places closer to home. We know that South Louisiana is incredibly important for birds. We get to see it during spring migration, but we've also quantified it in terms of the breeding population that the coast supports. Something like 3/4 of all of the eastern US breeding populations of sandwich terns nest in coastal Louisiana. Half of all the world's seaside sparrows nest in coastal Louisiana. 1/3 of all the brown pelicans now in the eastern United States nest in Louisiana. That's remarkable, right? They were extinct as breeders from coastal Louisiana in the 1960s. Conservation can work. They're a clear example of how conservation can work. We now have 1/3 of them. And you can go down the list, right? I don't have to say every single bird on this list, but it's remarkable how important coastal Louisiana is for particularly coastal water birds, nesting coastal water birds across the Gulf Coast and Atlantic coast of the United States. And the river built this land. 6,000 years ago, New Orleans, the land that New Orleans sits on, did not exist. The land that Thibodaux and Houma did not exist. Grand Isle did not exist. That has been built by the Mississippi River over the last 6,000 years. And the way that it's done that is that the river has shifted its course, and with the water that comes down the river come nutrients and come, most importantly, sediments. And it's that sediment that builds the land. And every about 1,000 years or so, the river shifts course as it finds its least passive resistance. It finds a new course and deposits sediment in that open water until it builds land and then has to shift course again. And that works in a cycle, right? So as the river is building land in one area, it's shown by this reoccupation here, other parts of the river that once flowed become disconnected from the main stem of the river. That wetland forms a barrier headland, much like what we see on the Elmer's Island area, Port Fourchon. That's a barrier headland today. Eventually that headland detaches from the mainland as subsidence and erosion takes hold, and we're left with the barrier island. And of course we see lots of barrier island chains in coastal Louisiana, like in Terrebonne and Barataria Bays and the Chandeleurs. And eventually those barrier islands submerge. But meanwhile, the river is building new land somewhere else. And unfortunately, what people have done is we've tried to control the river. The river no longer can shift course. It can no longer deposit its sediments back into the wetlands. And over the last 80 years, those wetlands are subsiding, they're sinking. They're going through, in part, the natural process that once always occurred. It's just that there aren't new areas being created. We see little slivers of examples of where the river is still functioning. So for example, the Atchafalaya and the Wax Bay outlets here in central Louisiana, and parts of the lower river, especially on the east bank of the river below the federal levee system. The river still is building a little bit of land, but by and large, the coastal Louisiana sediment starved. In addition to levees, we also got here through shipping and navigation channel that allows salt water to intrude the wetlands, stressing them. Oil and gas exploration has been a big driver of that. Of course, now with hurricanes and subsidence and sea level rise, all of these stressors are exacerbated. And so here's just another example, another sad example of Grand Isle and Port Fourchon from the 1930s to 2011. So 1930s, 2011. It's hard to imagine. And of course, if we don't do anything, the pattern will continue. So the Coastal Protection and Restoration Authority of Louisiana has worked with some of the top scientists in the region to project forward what future land loss would look like under different sea level rise scenarios. So in the 2017 release of the plan, this is how much future land loss is expected in the next 50 years under a low sea level rise scenario, and then a medium scenario. And we don't even want to think about a high scenario. Maurepas Swamp would become part of Lake Pontchartrain. Most of South Louisiana would be unrecognizable. It would be underwater. And the birds are showing us that these stressors are real. So one of the things that Audubon has done in the last few years is we've gone back and revisited surveys that were done by Phil Stouffer's lab while he was still at Southeastern Louisiana University. He had graduate students going out into Maurepas Swamp and counting birds in a very standardized, rigorous way. And so that allowed us to go back in 15 years later to do those same exact surveys. And we're finding that 50% of the prothonotary warblers that they counted 15 years ago are not there. Same with northern parulas, same with yellow-billed cuckoos, same with yellow-throated vireos, but not cardinals. There's the same number of cardinals. There's the same number of downy woodpeckers, the same number of chickadees, the same number of tufted titmice. There's something particularly traumatic happening to the neotropical migratory songbirds in Maurepas Swamp. And it turns out this study area is in the same location as the proposed river reintroduction into Maurepas Swamp. There's a restoration project being planned to divert Mississippi River water back into Maurepas Swamp to revitalize that system. The birds are telling us that we need that project to happen. We need that project to happen. The other thing we've done recently is we have modeled the relationship between bald eagles' nesting habitat and coastal Louisiana. And we've been able to show that there is a strong relationship between bald eagles and freshwater habitats. They don't like salt water. And we developed a model that was able to utilize the Coastal Master Plan, the series of projects, of restoration projects, to show that if we implement those projects in the next 20 years, we will have more bald eagles than if we don't implement those projects. And the same pattern will hold true in 50 years. We will have more bald eagles if we implement those projects than if we don't implement those projects. And the good news is we're implementing these projects. The state of Louisiana is projected to spend $1 billion in coastal restoration just this calendar year. $1 billion. We can thank, in some part, the Deepwater Horizon oil spill for that. It has provided a down payment into recovering the very stressors that coastal Louisiana is facing. The big projects that Audubon and our partners have our eyes on are these river reintroduction projects, right? So the Mississippi River built this land, it's been disconnected from this land, and one solution is to reconnect the river. And these are being done through what's called diversions, right? So you can either divert fresh water from the river or strategically place those diversions to capture fresh water and sediment. The Mid-Barataria sediment diversion just went through a public environmental impact statement. It was one of the most science-based EISs that most NGOs have ever dealt with. The amount of science that we've had planning of this project since 1984, the amount of science that went into that EIS was remarkable. it will build something like 50 square miles of land in the coming decades. And that will be bird habitat. That will be bird habitat for bald eagles, for king rails, and will help sustain our coastal wetlands. There's another one just a few years behind Mid-Barataria called the Mid-Breton sediment diversion. We think that the environmental impact statement for that will come out in the summer of 2023. From there, it'll take a year to have that final environmental impact statement approved. And from there, we anticipate another 2 to 5 years to begin dirt turning. Meanwhile, the Mid-Barataria will begin to turn dirt in really the next couple of years, which is going to be a major landmark for restoration in coastal Louisiana. The way these diversions work is punching a hole in the levee. They're controlling them. A lot of the expense of these things is that they actually have to get through other infrastructure. You have to get through the levee. You have to navigate bridges, railroad ties, coastal communities, all kinds of stuff. So you make sure that you're really installing these things correctly, because we have just so much infrastructure around the river now. But they're specifically designed to build land. You can model how to capture the most sediment out of the river. What angle does the input have to be? Where on the river? How high in the river, right? At the surface or the bottom? Those kinds of things have all been studied and studied and studied to maximize the sediment delivery possibilities of this. So those are super exciting projects. And this is just an example of a portion of the lower river where there is no levee. This is a willow forest that just established within the last year. People are standing on solid ground here. You would think that if you're out there in the wetlands, the marsh, you're just going to sink up to your hips. This is solid sand that people are standing on, and it's about to be a willow forest. This will be some of the first habitat that neotropical migratory birds see as they're crossing the Gulf of Mexico each spring. So that's really exciting. And I think, you know, as much doom and gloom as sort of I offered in this talk, the opportunity for restoration is massive right now in coastal Louisiana. I encourage people to be involved, to keep your eye on it. If you're curious about learning more, I'm going to offer my contact information. There will be times where we'll need public comments. We'll be calling on you to deliver those public comments, to let our decision makers know that coastal restoration is absolutely critical for birds, and that we can use the power of the Mississippi River to restore habitat for birds. So thank you. Thank you for spending the time with me. And here's some of our contact information if you'd like to learn more. And I will take questions if there are any.
I can't type that fast. That was great, Eric. Thank you so much. And back to what you said earlier, though, that we can do all we do here, but what about the other links in the migratory chain? How about the places, South America, Central America? Are they doing things like we seem to be doing here?
Depends. There's a lot of good work happening in Central America and South America. There are, it's pretty amazing. Like the birding community in Central and South America is very different than the birding community in the United States. It tends to be younger. It tends to be much more family oriented. Like kids are picking up binoculars at an incredible rate. There is an incredible movement going on in a lot of countries. I got to spend a lot of time in Brazil, and it was almost like bird watching like emerge out of nowhere. eBird has really played a central role. Like people are competitive about that stuff in Central America and South America. People are in their 20s and 30s and 40s, professionals that are doing other things are getting influenced by birds. So I think, the movement is being created. A lot of places are a little further behind, obviously, than we are. There's a lot of, poverty issues and development challenges that many countries face. But the government of Colombia, for example, is sort of in this really unique place. They have the most bird species of any country in the world. They have just come out of a 50-year civil war. There is a tremendous amount of international interest in developing Colombia, but at the same time, the government has recognized that ecotourism has to be part of the economic system. And so there are a lot of lands that are, either being put or proposed to be put into conservation. The other thing, that a lot of South American countries in particular have, to a lesser degree, Central American countries, are a lot of indigenous lands, frankly, that have been set aside. Enforcement and the protection of those lands is a whole other challenge, but at least sort of the framework is there. So there's challenges like everywhere. There's also opportunity. The other thing is there's just tremendous amount of endemism in a lot of those countries, places where there are bird species that are found nowhere else. Colombia is right at the top of that list. Peru is right at the top of that list. Bolivia is at the top of that list. And so that's also kind of a driver of conservation in a lot of those places. And if you protect those habitats that support endemic species, you're also protecting, our neotropical migrants, quote unquote, our birds that we're sending to Central and South America. We're actually borrowing from them, but that's a whole other thing. But yeah, I mean, there's tons of work that needs to happen everywhere. I will say too, organizations like American Bird Conservancy have done great work working with local partners down there. The National Audubon Society has a program called Audubon Americas, where we work with international partners. We have a lot of great work with the Panama Audubon Society in Central America, protecting mangroves and doing water quality work and shorebird work. Places like Save Brazil is a really strongly emerging NGO in Brazil that's a partner of BirdLife International, and they're doing a ton of tremendous work on migratory shorebirds and putting land into conservation. And so if folks are inclined, I mean, absolutely, like look up some of these local groups, local, right? I mean, they're countrywide groups in many different countries, but pick your favorite place to go birding in the neotropics and support the infrastructure in those countries.
So we should also try to make trips to go there so they can see the tourists. Okay.
And hire local guides.
Hire local guides, yeah. Okay.
I mean, it's great to bring in international guides, but a lot of the international tour companies now are also partnering with local guides so that they get a cut of the money. And frankly, they're the experts. And it's amazing. Some of these guides are just, I think as North American birders, we often rely on finding birds by movement as such an effective strategy for looking for warblers up in trees and things like that. It's a different strategy when you go to the tropics. You have a lot of really cool birds that are sit and wait predators. They're ambush predators. Things like puffbirds and trogons. And so they just sit there motionless in trees. And these guides are just phenomenal at finding shapes in the forest and finding birds that are completely motionless in the forest. Potus are another great example of that, right? So yeah, those local guides can be absolutely incredible.
Eric, you have a couple of questions in the chat, at least one.
Okay. I can find my chat. You're right, Jane. It did move my screens around. Yeah, I'm gonna.
So the question is, can you address the progress on the Mississippi Valley bottomland hardwood redevelopment?
Yeah, so the Lower Mississippi Valley joint venture has identified sort of priority conservation reforestation regions. And a lot of that is being implemented through what's called the WRE program, the Wetland Reserve Easement Program, which is a farm bill program through the USDA. It's one of these cost share programs where landowners or conservation organizations will fundraise or put money towards reforestation projects, and the federal government through the farm bill provides additional funding to increase the area and acreage and management of those habitats. So that was a program that really took off through the LMAV really about 20, 25 years ago. And there's a lot of land now that's been put into that and still kind of early successional. I think one of the challenges that we're facing right now is what to do with that. So those forests need some kind of management in a lot of cases, either thinning or some sort of strategic diversification, or more or less water, things like that. And I think that's going to be a real challenge for the coming decades, while we're also trying to enroll more private landowners into this conservation easement program. So there's, still way too much developed land in the lower Mississippi Alluvial Valley, but there are initiatives and there is progress in recovering that. But it is slower than it probably should be or could be. It's just, conservation is not cheap, unfortunately. Once you kind of destroyed a system, it takes a lot of money to recover that system.
Another question, does Baton Rouge Audubon ever arrange tours? I assume that was directed at the Central America, South America, and that is not something that we have ever gotten into. Usually people just find a group of friends and find a tour guide or a tour group and go on their own. Let's see, somebody asked, where are the tacking towers? I think maybe tracking towers in Louisiana. I have seen them in Cameron Parish. I think she's referring to the Modus towers.
Yeah, there was a whole network of we call automated receiving stations that detect these very high frequency tags, all in the same, they're all in the same signal, and the individual tags have that unique coded information embedded within the frequency. And so the computers on those towers can interpolate which tag is being detected. So there was one at Pevedo Woods. There were several on the Grand Isle area, some on the Barrier Islands. There were a few around Rockefeller and elsewhere across coastal Louisiana. Unfortunately, with our pretty nasty 2020 hurricane season, almost every single one of those was taken out. So the Department of Wildlife and Fisheries is kind of in charge of managing that program. They were the ones who set it up. They're looking at more permanent sources of infrastructure to rebuild those towers. So hopefully in the next year or two, we'll have that network up and running again. But that Modus network, that's all around the hemisphere, right? There are towers found. It really started mostly in the Northeast and around the Great Lakes. There's incredible infrastructure up there. But there's sort of an effort led by the state of Missouri, their wildlife department, to put more towers up across the central part of the United States, working with other state partners. They got one of these multi-year, multi-state wildlife action plan grants. They're also talking about adding towers to the Yucatan. Actually, Katie Percy and I went down to the Yucatan a couple years ago and put a couple towers out there as part of our prothonotary warbler work. But those also need to be refurbished at this point. They fortunately haven't been destroyed in a hurricane, but those things just kind of take maintenance. So yeah, there's a lot of interest around that and sort of better utilizing that system to understand bird migration.
Great. Another question regarding your stats on bird decline in Louisiana. What evaluation is done on increases in other regions which may indicate changes in migratory patterns?
Yeah, I mean, it's a complicated story in a way because it can be very bird specific or guild specific. When you might be referring to the like 50% declines of the prothonotary warbler and the parula within Maurepas Swamp. That was a very kind of localized study, but we know that things like prothonotaries and parulas within the broader region of the southeastern United States haven't declined that rapidly. They've declined by like 10% in the last 15 years, but not 50%, right? So there's something particularly insidious going on within Maurepas Swamp, and a lot of it we think is related to the lack of the nutrient input that the river once had there. So it's kind of a relic deteriorating forest. So maybe particularly stressful for insectivorous birds. But I mean, other things like, what's a good example? You know, trying to think of, so common grackle is actually kind of a good one. There are places of the country where they're declining like crazy, and other parts of the country where they're increasing. So we're seeing kind of these shifts in population. Henslow sparrows kind of gone through a similar thing. They've been extirpated from New England over the last 50 years or so, but at the same time, they're expanding westward. So another one of these farm bill programs actually pays farmers to keep some of their fields in grassland rather than, so they actually get paid to not farm their land in a way. And that is called the CRP program, or the Conservation Reserve Program. And that has benefited Henslow sparrows, where that program has been really popular, particularly in the Midwest. So yeah, I mean, it's really, it can be a really complicated story. We know that prothonotary are actually expanding their range northward a little bit. So in places like Ohio, they're maybe becoming a little bit more abundant in Wisconsin, but you know, across the whole part of the range, they're disappearing. So, you know, climate change is intersecting with how these populations are adjusting and shifting, both in terms of the breeding distribution, where they're increasing, where they're decreasing. And climate change has impacts on these birds as they're migrating and on their wintering grounds too. So it can be a pretty complicated story. And in terms of, you know, what's going on where and how localized and versus how regional. So these are all the kind of things that conservation biologists like myself kind of keep us up at night. But I think the big story is, like, we just need to put as much land into conservation as we can, as fast as we can, and simultaneously make the world more resilient to climate change, which will benefit birds, benefit people, will save all of us trillions of dollars and that kind of thing. So.
And I think birders can also contribute to that. You know, our eBird data contributes to the picture of where birds are and where they're moving. You know, so we as citizen science can help identify those trends, both the decreases and the increases as birds are moving around. So all of us can participate in that. Couple more questions. Ann Riley's asking, is anybody looking at what at the Louisiana coastal wind farms and what the farm's effect will be on migration?
Yes. So yes, Audubon is involved in those conversations. We have some policy folks that are working on it, both that are based in Louisiana and that are based nationally. So like our DC office. Yeah, it's a big discussion. The technology has really gotten to the point where wind development in the Gulf is becoming feasible. You know, 10 years ago, it was still a pie in the sky sort of dream. The winds just weren't going to be favorable enough. It was too expensive, so on and so forth. But that's all changing. Of course, U.S. Fish and Wildlife is involved. They, you know, are the lead agency that regulates all things associated with bird take or bird mortality. So there are a lot of conversations. One thing, I mean, it's a little bit of a red herring. I know folks get very concerned. You hear things in the news all the time about wind farms and killing birds. But if you put it in comparison, right, to some of the other threats, it's pretty minuscule and it's pretty localized. Neotropical songbirds that migrate at night don't tend to have major issues with wind farms in most situations. The lighting on wind farms is actually kind of is kind of a big issue to look at. So birds, like I mentioned, that migrate at night, they use stars, they see the magnetic field. And when you flood the sky with light, like cities and towers and things like that, that disorients birds. And our oil and gas infrastructure in the Gulf of Mexico has been estimated to kill something like 300,000 birds every spring, because instead of flying across the Gulf, they see these structures with lights on them and they start circling those structures. They get disoriented and they get exhausted and then fall out onto those structures where there's no food and no water. they perish, right? So are wind farms going to add to that problem, or are they eventually going to replace oil and gas? You know, the lighting on a wind farm is going to be much more dispersed than it would on a structure, so maybe less of an issue. So those are all the kinds of things that, you know, bird conservation organizations are looking at and discussing. There are also plans to put together monitoring strategies. There are all sorts of really cool technologies now with localized radar, right? So I mentioned that radar can detect bird migration. Can you put a little radar on these wind farms and actually turn them on and off during, you know, sort of the key bird migration nights, those kinds of things. So all of that is on the table. That's all being discussed between the federal agencies and NGOs like Audubon and other groups. So absolutely, it's a great question, and we're on it. So if folks are interested in that, I'd love to share more with you.
One of the things that's worried me about wind farms off the, you know, actually in the Gulf is how they could possibly ever accurately measure the mortality rate, because the bodies would fall into the ocean and be eaten, and you don't know what's going on. You have no idea. It's hard enough on land.
One way you could do it.
But
one way you could do it is with radar. So you have a radar pointed forward and a radar pointed backwards, and you can measure the difference in the radar signal.
Okay, that's good. All right, we'll take one more question. Lawrence had a question specifically about the what you're talking about with migration. He says, you mentioned that a cytochrome, I believe, was detected in the eyes of birds and helped them to detect the magnetic field to help them with migration. So is it possible that the cytochrome can detect a specific signature from the magnetic field that helps each bird species move back and forth along the same migratory trajectory?
I don't know. I don't often try to say I don't know to something, but I don't know. That goes beyond. I'm not even sure that's known to science. We're just at the precipice of understanding how birds are doing this.
Even understanding that they're doing this at all, much less that specific. Well, maybe there's some research we can recommend for Lawrence.
Yeah.
All right, we'll wrap up there. Appreciate everybody coming out tonight. Eric, we appreciate you so much for taking the time to do the presentation. It was very well done. We love your enthusiasm and your expertise, of course. So thank you, everybody, and good night.
Thanks, James.
Hi, everyone.
Thanks, everybody.
Happy fall migration.